Understanding the time complexity of the for loop. One of the fundamental aspects of coding is understanding the time complexity of your algorithms. Calculating the time complexity helps in determining the efficiency and performance of your code. This guide focuses on a crucial question: is the time complexity of a for loop O, n, or O, n superscript 2? Basics of time complexity. Time complexity describes the amount of time an algorithm takes to run as a function of the length of its input. The two common time complexities that often come into question are O, n linear time complexity, O, n superscript 2 quadratic time complexity. Understanding these basic terms sets the stage for analyzing a simple for loop. Analysis of a single for loop. When we examine a single for loop, a common question is whether it has O, n, or O, n superscript 2, time complexity. Let's consider the following basic form of a loop in languages like Java or C++. In this example, the loop runs n times. The operations inside the loop execute in a constant time, denoted as O(1). Combining these, the overall time complexity of this for loop is O(n), because the loop iterates linearly with respect to n. Analysis of nested for loops. Complexity increases when we deal with nested loops. Consider the following nested loop. In this case, the outer loop runs n times. For each iteration of the outer loop, the inner loop also runs n times. Inside the inner loop, constant time operations occur. Since each iteration of the outer loop triggers an entire set of n iterations of the inner loop, the inner operations occur n*n times, resulting in O, n superscript 2, time complexity. This quadratic time complexity signifies essential difference in performance for large n compared to a single loop. Best practices and conclusion. Understanding whether your for loop has O, n, or O, n superscript 2, complexity can drastically impact the performance of your program, especially for large inputs. Employing nested loops inherently increases time complexity, making it crucial to optimize and reduce nesting where possible. Monitor and analyze the structure of your loops closely while coding. Strive to implement algorithms with lower time complexity for efficient execution and scalability. Understanding these nuances ensures you can build optimized and high-performance software.